Now let's go over the different network appliances that we may see in our infrastructure and that we can deploy and manage to protect our enterprise infrastructure. So the first thing we're going to talk about is the jump server. So a jump server acts as a secure and controlled entry point into a network segment or environment from a different network. So essentially with a jump server, we're going to remote into that jump box or server instead of directly going to our enterprise or ICS systems. So just kind of like that man in the middle, that's going to allow us to still keep that separation between our different networks there, but allowing us to remote in from a single entry point here, that jump box. A proxy server. So we're going to have two types. We're going to have a reverse and a forward proxy. So a proxy server acts as an intermediary between end users and the internet, providing security, monitoring, control, and also some like caching services, right? So it gives us privacy by masking the IP address of users or the web servers, depending on we have a forward or reverse. It can do content filtering. So that proxy, if it's forward, it can say, hey, sorry, users, you can't go on YouTube. We're going to block that. And they can also do caching, depending on what kind of proxy server you may have, where it's going to store local copies of frequently accessed resources. This is going to improve response times and reduce bandwidth usage. IPS or IDS systems, something we've talked about a lot in this Security Plus course. So IPS and IDS, critical components that are going to sit in line if they're network-based, or they could be host-based as well. So the IPS, we get active security that's going to monitor and take immediate action. With IDS, we're going to passively monitor and alert administrators of suspicious activities. That's going to require manual intervention. So how can we detect and prevent? We could do it via signature-based. So looking at signatures of previous vulnerabilities or malware, malicious network traffic, then anomaly-based. This is going to be like our heuristics-based as well, right? Where we take patterns, we look at the behavior of our network, and we say, hey, this goes beyond or deviates from that behavior. Let's do some prevention or alert our administrators. All right, a load balancer. So a load balancer efficiently distributes incoming network traffic across multiple servers to optimize resource use, maximize throughput. So this is going to allow the distribution of traffic to maybe like our web server cluster. It's going to increase our availability and redundancy, and it's going to allow us to facilitate easy scaling of server resources to meet varying traffic demands, okay? There's going to be a lot of different ways we do load balancing. We can do this just based off TCP, SSL offloading. We're going to have different load balancing algorithms like round robin, agent-based. We could have load balancing that uses like maybe not specifically AI, but it's going to look at the load on that server, right? So load balancing, it's also going to provide what's called a virtual IP address. And that's going to be either A, what users connect to, and then distributes that load to our web server cluster, or B, it could be the default gateway for all those web servers using that virtual IP address. All right, sensors. So in a network, sensors are deployed to detect and respond to changes or events, providing data for monitoring and security purposes. So sensors, they can do data collection, threat detection, and event notification. And there's something we can install like our SIEM systems. They're going to be sometimes just embedded into that server to say, hey, we want to report back our system health. We can do this using like SNMP, OIDs, or maybe using like APIs. Port security. So port security, when managing layer 2 traffic, is going to allow us to do MAC address limiting. We can do sticky MAC addressing where we say, hey, we want this MAC address only to access this switch port. And then it's going to allow us to do actions in case that port security gets tripped, where we can either shut down that port, or we can do restrict and protect mechanisms, which will send up a syslog that potentially we could send to a syslog server that then we're monitoring or getting alerts from to see if port security has been tripped. So when we say trip port security, what I mean by that, if we set a maximum of 2, if a third computer tries to get plugged into that port within the 5-minute period of that MAC address table flushing out, that's going to trip port security. It's going to send this interface into an error disable mode that then we will have to manually go and shut and no shut and do some investigation into why multiple MAC addresses were coming across that port. 802.1x. So 802.1x is a network protocol that's going to provide us authentication and authorization for network devices and objects trying to get on our network, okay? So this is going to be, it's not exactly a AAA protocol, but what it is going to provide for us is NAC, Network Access Control, and typically it's used in conjunction with AAA protocols like Radius. So we're going to have port-based network access control. It's going to grant network access only after successful authentication of devices. It's going to have EAP integration. So we can use 802.1x with the extensible authentication protocol or framework, typically in our wireless LAN connections, and also can be used in services like Cisco ICE, Identity Services Engine, to allow network access control for any device plugging in to our network. Extensible authentication protocol. So EAP is a framework that supports multiple different authentication methods for securing network access. So this is where we're going to have a supplicant, an authenticator, and an authentication server, all working in conjunction to do secure authentication. So with EAP, we're going to have a bunch of different methods, okay, guys? It truly is just a framework for you to build authentication methods on top of. So it operates on the data link layer, allowing it to be used over different network types, whether that be wired or wireless, and can be integrated with enterprise scale authentication services like Radius. I've never seen Diameter used in real life, but maybe, right? Making it suitable for large organizations. Firewall types. So we know firewalls are there to filter inbound and outbound traffic, but there's going to be a lot of different types of firewalls. So we're going to have our basic layer 3/layer 4 firewalls that are filtering based off IP address, port, and protocol. We're going to have our layer 7 firewalls that are filtering based off content, right? URL filtering based on the application traffic. We're also going to have stateful firewalls, which tracks the state of active connections and makes decisions based on the context of the traffic. Now, something to note here. We're talking these layer 7 firewalls. These are typically going to be labeled as next generation firewalls. And to do proper layer 7 filtering, you're going to have to install or configure SSL/TLS decryption, right? Because in our client to server architectures, from client to web server accessing a web page, we're going to use HTTPS, right? TLS and SSL. Web application firewalls. So a WAF protects web applications by monitoring and filtering purely based on HTTP traffic. So this is going to give us protection from common HTTP-based vulnerabilities like injection attacks, cross-site scripting, cross-site request forgery attacks. A UTM. So think of a UTM as just an appliance that's going to give us a bunch of different security functionality. So this isn't going to be like we go out on the market and say, I want a UTM appliance. This could be like me buying a Ubiquiti router, a Dream Machine Pro, and getting the ability to do VPNs, layer 2, layer 3, IPsec VPNs, the ability to do IDS, IPS, to do firewall statements, to set up anti-spam. And now that could be considered my UTM device. So this is going to offer us a single management interface for multiple security functions. Okay, layer 4 and layer 7. So we're going to, right now, we talk about layer 4, layer 7. Obviously, these are the layers on the OSI model, but this is going to be how we potentially can do filtering, right? We can filter based off that transport layer, going over the different the different ports and protocols, or we can filter based off the application layer, actually looking at the application-specific protocols and packet payloads. Okay, let's do our check on learning. Let me bring this into view. Okay, so now we're going to go over domain 3.2. That's going to be principles to secure enterprise infrastructure on network appliances. So question 1, which of the following is not a typical function of a proxy server? Let's go ahead and take a look at our options here. So caching frequently accessed content to improve response times, filtering content based on organizational policies, performing stateful inspection of network traffic, or D, providing privacy and anonymity by masking the user's IP address. So obviously, guys, it says key here is which is not a function, and that's going to be C, performing stateful inspection of network traffic. That's going to be like a stateful firewall. Question 2, what differentiates an IPS from an IDS system? So it's going to be C. IPS actively monitors to prevent potential threats, whereas IDS passively monitors and alerts administrators. All right, question 3. Which of the following best describes a unified threat management system? So A, single security solution that consolidates multiple security and networking functions within a single appliance. B, a type of software designed to exclusively for data encryption and decryption. C, a network protocol that ensures secure data transmission between client and server. Or D, a device that solely focuses on filtering spam. We're going to go with A, right? That's a device that consolidates a bunch of security functions. Question 4, what is the primary purpose of a web application firewall? So that's going to go B here, guys, to protect web applications by filtering and monitoring HTTP-specific traffic. Question 5, which of the following best describes the primary benefit of implementing network appliances within an enterprise infrastructure? So we're going to go with B, to perform specific functions like routing, switching, or security to optimize network performance. Question 6, what is the primary security function of a jump server in enterprise infrastructure? That is going to be B. It acts as a bridge between different network segments, providing a controlled access point.